Hello, we are Madhu, Anushri and Tanvi from ES116. Today we are presenting our mini project, a smart door lock system which we built using an Arduino Uno. In our daily life, traditional locks depend on physical keys which can be easily lost, duplicated or misused. So we thought of creating a simple and affordable smart lock that improves security using digital methods. Our system allows access in two ways, either by scanning an RFID card or by entering a 4-digit PIN using a keypad. This gives flexibility to the user and also adds an extra layer of safety. Now we will show you how the system works step by step, starting with the components we used. Let's first look at the components in our project. At the center we have the Arduino Uno, which acts as the brain of the system. It controls all the input and output and runs the program we have written. On the right side we have the RC522 RFID module. This module reads RFID card wirelessly using radio frequency signals. Each RFID card has a unique ID and the system checks whether that ID is authorized or not. And also we have a 4x4 keypad. This allows the user to manually enter a pin. It has a number from 0 to 9 and a special keys like star and hash for control functions. At the top we have an I2C LCD display. This is used to show messages like enter pin, access guaranteed or access denied. Using I2C helps reduce the number of wires needed. At the front, at the left, we have a servo motor. This acts as the locking mechanism. When access is guaranteed, the servo rotates to 90 degree to unlock, and after a few seconds it returns to 0 degree to lock again. Finally, the whole system is powered by a 5-volt adapter, which makes it portable and independent from laptop. Now let's test the RFID functionality. We take a registered RFID card and bring it close to the reader. The module scans the card and sends its unique ID to the Arduino. The Arduino checks the ID with the stored data. As you can see, the LCD displays access guaranteed and the servo rotates to unlock the door. The lock remains open for around 10 seconds, giving enough time to access, and then it automatically locks again. Now let's try an unregistered card. We scan this card. The system reads the ID, but since it is not stored in the program, the LCD displays access denied. The servo motor does not move, which means the door remains locked. This shows how the system ensures that authorized user can enter. Now we will test the keypad. We enter the correct pin 1, 2, 3, 4 and then press the hash key to confirm. The system verifies the pin with the stored password. As you can see, access is guaranteed and the servo unlocks again. Now let's try an incorrect pin. We enter 4, 5, 6, 7 and press hash. The LCD shows access denied and the lock doesn't open. Also, if we make a mistake while entering the pin, we can press the star key to clear the input and start again. This makes the system more user friendly.
While building this project, we faced several challenges. Initially, when we connected all components together, the power from the laptop USB was not sufficient. Some parts were not working properly, especially the servo motor. So we switched to a 5-volt adapter for stable power supply. Another issue were the RFID module. At first, it was not detecting the cards. So we wrote a separate test code that prints the card's UID on the screen. Once we got the correct UID, we added it to our main program. We also faced problems with the keypad. The rows and columns were connected incorrectly, which caused wrong numbers to appear. We had to carefully check the wiring and test each button one by one. When we connected everything at once, the system became unstable, so we divided the project into stages. First, we tested the servo and keypad, then added the LCD, and finally integrated everything. We also had to install the correct versions of libraries for RFID, keypad and LCD. Sometimes incompatible libraries caused errors in the code. Lastly, some jumper wires were loose, which caused random issues. We had to secure all connections properly to make the system reliable. Before building the actual hardware, we used simulation tools like Wokwi and Tinkercad. Anushri created the stimulation to test both the circuit and the code. This helped us identify mistakes early and save time during real implementation. In our team, each member contributed equally. Madhu handled the physical connection, assembled the components, and prepared the project report. Anushri worked on coding, stimulation, and debugging the system. Tanvi focused on testing, fixing wiring issues, and arranging the final setup so that it looks neat and presentable. To conclude, we successfully built a smart door lock system using Arduino. It supports two authentication methods, RFID card and pin entry, making it both flexible and secure. The system provides clear feedback through the LCD and operates independently using a battery. This project can be further improved by adding features like mobile app control, fingerprint sensors, or internet connectivity. Overall, it is a simple, practical, and cost effective solution that can be used in hostels, lockers, or small offices. Thank you for watching.